in this lecture series video of electric circuit analysis. Today's topic is about Thevenin's theorem. So problem number 2. In the previous video we have discussed about the problem 1 where we find out the I value in the total circuit. So here in this problem number 2 we have to find the value of Thevenin, Thevenin, the load current IL flowing through the load resistor and the load voltage across it in circuit using Thevenin's theorem. We have to find out the load resistance, load current, Thevenin, Thevenin flowing across the load resistance and the load voltage. So here we have a circuit of that which we are going to solve the Thevenin's theorem. So the first resistance is 12 kilo ohms, 8 kilo ohms, 4 kilo ohms and 5 kilo ohms. So 5 kilo ohms is your load resistance. So here the voltage value is 48 volt. So in basically we will short circuit the voltage value. So in this step 1, open the 5 kilo ohms load resistance. So here we can open the load resistance. So that is mentioned as A and B. So 50 volt is open circuited by using the step 1. So in step 2 we have to find out the Thevenin value. So Thevenin value is equal to 3 microamps into 4 kilovolt is equal to 12 volt. So this 12 volt is your Thevenin's value. So we find out the Thevenin's value and open circuit the load resistance. In the step 3, so basically in Thevenin's theorem we have 3 procedures. Open the load resistance, open circuit the voltage, short circuit the voltage and open circuit the current value. So here, so the first 2 steps are completed. So we are going forward for the step 3. So open circuit the current sources. So here we don't have any current sources. So we can open circuit. We can don't have any other current circuited. So we keep the circuit as well as open circuit with the load resistance value. Here, so the 8 kilovolt plus 4 kilovolt and 12 kilovolt is in parallel. So these parallel value is substituted by using the parallel formula. So we can get the Thevenin value is equal to 8 kilo ohms plus 4 kilo ohms into 12 kilo ohms divided by 4 kilo ohms plus 12 kilo ohms, which is known as your parallel circuit formula. So applying the parallel formula we can get 3 kilo ohms. So Thevenin is adding all the resistance value in the circuit. By adding this value 8 plus 3 ohms is equal to 11 kilo ohms. So we find out the Thevenin value as 12 volt and Thevenin value was 11 kilo ohms. So next we have to find out the load resistance and load voltage. So for load resistance and load voltage we can draw the equivalent circuit where we can apply the Thevenin's and R load resistance value. So applying this, I is equal to V by R. So Thevenin's value formula we know that I is equal to Thevenin's by R Thevenin divided by RL. So here we are going to find out the load current, so that we mentioned it as IL. So IL is equal to your load current Thevenin divided by R Thevenin plus load resistance. IL is equal to, so substituting the Thevenin's value as 12, R Thevenin as 11 and RL is equal to 15. We can get IL is equal to 0.75 milliamps. So after that we have to find out the load voltage value across the circuit by using the Thevenin's theorem. So by applying the Thevenin's theorem for find out the load voltage, IL is equal to RL. So P is equal to IR format. So these formulas are associated more with the Ohm's law. So by adding the load resistance of Thevenin's value, we can differentiate it. Otherwise, a basic Ohm's law is applied here. P is equal to IR. So we have to find out the load voltage, so that we are rewriting this as load current and load resistance. So VL is equal to IL is equal to 0.75, RL is equal to 11 kilo ohms. So we can get VL is equal to 3.75 volt. So by applying the Thevenin's theorem, we can find out the Thevenin's value as 12 volt, Thevenin value was 11 kilo ohms. Load resistance value IR is equal to 11 kilo ohms, whereas IL or RL or Thevenin is equal to same value, similar value. So load current IL is equal to 0.75 milliamps and the load voltage value is equal to 3.25 volt. Thank you.